Hello everyone, I'm Aditya Shrivastava of grade 8 and I'm from Father Agnes School in Noida. Today we are going to discuss some of the greatest human discoveries by one of the most brilliant minds the world has ever seen. We are going to discuss Stephen Hawking's theory about black holes, also known as Hawking radiation. Let us first give a tribute to late Stephen Hawking by giving him an introduction. Stephen William Hawking was an English theoretical physicist, cosmologist and author who was director of research at the Centre for Theoretical Cosmology at the University of Cambridge. His education was completed at Oxford University and he had a job at Cambridge University. Some of his most famous books were A Brief History of Time and Brief Answers to Big Questions. He is known for he has been known for performing groundbreaking work in physics and cosmology. Because of him and his books, of course, science has become accessible to everyone. First, to give a solid foundation to a law, we should understand about what are black holes and how are they formed. The term black hole is of very recent origin. It was coined in 1969 by the American scientist John Wheeler. A black hole is a region of space-time where gravity is so strong that nothing, no particle or even electromagnetic radiation such as light or sound can escape from it. Now let's discuss how a black hole is formed. A star is born when gravity forces a huge volume of mostly hydrogen gas to collapse in on itself. The burning of fuel of the star causes the star to get smaller and smaller day by day. This process can take billions of years or maybe millions of years or trillions of years according to the star's age and size. The fuel of the star is mostly hydrogen atoms, but due to excess of pressure they form helium atoms, and when the helium atoms fuse they form carbon atoms, and this process continues until finally iron is synthesized. This process again may take to give billions of years to settle in because it is a very tedious process and it takes a lot of pressure to synthesize in iron. The fuel of the star is over, it starts to cool down, and over this period of time the star starts losing its own mass, and eventually the star's own gravitational pull will get the better of it and it will start absorbing its own mass. It is like a tsunami epicenter is bringing water in itself. It's like a whirlpool. The star becomes a type of whirlpool. Eventually, a star's own gravitational pull will start absorbing its own mass and it collapses. The explosion will be more stronger than nuclear explosion, and all that will remain will be a remnant core. The core contains all the mass of the star that is absorbed. There's a very powerful gravitational pull. It is like 10 of our suns is squeezed into a sphere of size of diameter of New Delhi. So minute. Before we get on to Hawking radiation, we should understand the most important part of it: particles and antiparticles. What are particles and antiparticles exactly? A particle is a small localized object or entity to which can be ascribed as several physical or chemical properties such as volume or density. This is said to be the smallest atom or unit in the universe. And what are antiparticles? A subatomic particle having the same mass as a given particle but opposite electric or magnetic. Now let us get into Hawking radiation. Hawking radiation is a black body radiation that is predicted to be released by black holes due to quantum effects near the black hole event horizon. It is named after the physicist Stephen Hawking, who provided a theoretical argument for its existence in 1974. In simple words, it is a type of rays or waves emitted by a black hole, and it's like a black hole is leaking. There are trillions of particles in the universe and millions dissolve and form every second. Every particle in the universe has an antiparticle to it. When the particle and the antiparticle meet, they annihilate each other. And if this occurs near a black hole and one of the two gets trapped in the gravitational pull of the black hole and gets dissolved into it, and the other one which escapes from the black hole is seen as energy emitted by the black hole. The particle which escaped contains positive energy, and the one which does not escape contains negative energy. The particle which escapes and has positive energy is known as Hawking radiation. I would love to go into more detail as I've prepared for it. I would have given you an insight on the theory of relativity and quantum mechanics if time wasn't short, and I have prepared about it too as a matter of fact. And I would like to quote a very funny quote by Stephen Hawking. He said, "Life would be tragic if it wasn't funny."